if we look at speciation events in nature, allopatric speciation that we mentioned with the geographical divides is one of the most common to see. Island chains, we see a lot of these speciation events. Darwin's finches, of course, fall into this category, and the tortoises fall into this category. They've been separated on individual islands, and they've stopped interbreeding with the original parent strain. But what we have to look at is, okay, what does that mean based on the ecological species concept? So this actually says a species is defined by the resources that it uses. All right? So these are cichlids. I know they're a little fuzzy for you. Sorry about that. But these are cichlids. And what they look at is these cichlids have actually divided based on where they feed in the water column. So one set feeds at the top of the water, and one set feeds at the bottom. Now you see similarities between these, right? These guys were originally one species, but now they've divided out, okay, in all the cases here, have divided out and now don't interbreed because of spatial issues. Okay, so this is again a temporal or a spatial kind of separation. They're not breeding because they're not in the same location to do so. Your mate may be in Siberia, but if you don't find that mate and breed with them, you really are spatially separated, right? So this is a barrier to reproduction. Species can be faster with availability of new niches. So what's a niche? So a niche means that you're fulfilling some available resource, or you're taking advantage of some available resource in the environment. New environments, new niches happen all the time. We mentioned island formations. These can happen from all sorts of major changes in the environment. Could be earthquakes, could be landslides, could be volcanoes. It doesn't matter. But the idea is we now have something called adaptive radiation. You take an original population, and that original population gets split out into these little pockets or little niches. And when it does, if the resources work for that smaller population, then they'll stay there. There's no reason for them to move back to the original parental population. So what happens is over time, these populations will divide out and never come back together. When this happens, we get new species very quickly. And those new species will actually stay isolated and separated. Even if you brought them back together, they still wouldn't mate. So adaptive radiation is something we see after major events, mass extinctions, volcanic eruptions, earthquakes, things like that, that are going to allow particular individuals to colonize and take advantage of resources in an isolated pocket or environment. So I give you a couple of finches here. These finches started from the exact same original parental population thousands of years ago. Now they wouldn't even give each other a second glance for mating. They're very different. You see that, okay? But they all came from the original same population of parental finches thousands of years ago. The idea here is that they have now taken advantage of specific environments. All right, so I've got my seed eater down here at the bottom. He sits on the ground and eats seeds. Well, I've also got a seed eater that sits in the cactus and eats seeds. But if I put my cactus finch on the ground, took away all of his cacti, he wouldn't survive. He has no idea how to eat seeds on the ground. So what we have to look at is they've isolated themselves, but by doing that, they've expanded the resources available to them, because now they're eating particular areas and they're not competing for resources. This is amazing for a population. If you don't have to compete for your food, and I don't think many of you are competing for lunch, but imagine if you walked into Gracie's and you had to compete for food in the cafeteria every single day, how that would affect your fitness and how that would affect what you eat in a given day. We can get sort of overlap between these pockets, and what we call hybrid zones. So after the species have kind of separated out, they might overlap in a particular area. Sometimes they'll decide to interbreed. Sometimes they'll remain separate populations. When they decide to interbreed, even on those borders, and this would be limited overlap, we get something called hybrid zones. So over time, those hybrid zones can actually be maintained if the individuals in that hybrid zone or that overlap area only breed within that area. They don't go back to their original populations. So now essentially we've taken two bordering populations. Where they border, they've started to mate. That mating border has now started to be maintained as a hybrid zone, meaning eventually you could get 3 different species going on here. Kind of cool, okay? But you can also completely reverse speciation by having species overlap completely again. So instead of just having a hybrid zone, you may get a full overlap of these two bordering populations, full mixing of both gene pools. If that occurs, you've essentially taken evolution backwards. Those speciation events that occurred, that division that occurred, will actually be lost. And that's okay. It's just how it works. So this figure kind of steps you through what I just discussed, this breaking of the species and this adaptive radiation kind of thing going on. New species are formed, but then we get some sort of hybrid zone here in the middle where a couple of individuals may hybridize, may start a whole new species. You may end up with, instead of 2 species here, you may actually end up with a third. Whether or not that gene flow is maintained will then affect whether or not these populations actually stay separated long term.